Hello. Alright, today what we're going to do is learn about the slope of linear functions. So we're going to be studying what's basically a line. We just use the word linear function to let you know it's a straight line. Learning goal, you will be able to find the slope of a linear function, and we will get into it eventually, but not today, to find slope from two ordered pairs. So for the notes page, I want to go over some of the instructions first before we get into that. Again, the title, Finding the Slope of Linear Functions. And as we've covered before, you have your space for writing the summary. I'll also start with the previous knowledge that you should have. You should be fully aware, absolutely comfortable knowing about the coordinate plane, that the vertical axis is the y-axis, the horizontal axis is the x-axis, and that we move from negative x to positive x this way, from negative y to positive y this way. So that you have to be perfectly comfortable with. You also need to know and be perfectly comfortable with ordered pairs, knowing that the x-coordinate comes first, then the y-coordinate. That the y-coordinate depends on the x-coordinate. You have to be comfortable with adding and subtracting positive and negative numbers. If you still make errors with that, make sure that you clean that up before jumping full into finding the slope. Also know about how to simplify fractions and equivalent fractions, like -1 over +2 is the same thing as +1 over -2. You have to be comfortable with all that knowledge. And if you need help with any of that beforehand, find ways to clean that up through extra studying on your own. So now what we'll get into is the definition of a linear function, which is very straightforward. The graph is a straight line. Okay, so a linear function, the graph of a linear function is a straight line, not a curve. So a straight line this way, this way, this way, linear function. Okay, straight line. There are three main characteristics of a straight line that we will eventually study. Okay, three main characteristics. There is the x-intercept, which is where the straight line may cross the x-axis. There is the y-intercept, where the straight line would cross the y-axis. And there is slope, which is basically the rate of change of that line. How much slantiness, I guess you can call it, that's the slope. So we're going to be studying slope. Of all the three characteristics of a linear function that we can study, we're going to focus on slope. So, what is slope? Slope is the rate of change in a linear function. Okay, so how much does the line change over time? And I'll be more specific. But that is the definition of slope. It's the rate of change in a linear function. And so we have a couple of things that look like formulas here. You have the rate of change in the y over the rate of change in the x. Okay, so the rate of change in the y over the rate of change in the x. That is the definition of slope, or the formula for slope. I use the Greek letter delta to represent change. That's what delta stands for, change. So the change in y over the change in x. And that is slope. So, the question you must ask in determining slope is y going up or down as x increases? So the question to ask in regards to slope, is y going up or down? Is y getting bigger, or is y getting smaller as x increases? Okay, so as x increases, as x continues on going into the right direction, does the y value go up or does it go down? Okay, does the y value increase or does it decrease as x increases? So you always, as x increases, you're looking at x increasing. Does y go up? Does y go down? This lets you know if you have positive slope, that's if the y is increasing, negative slope if the y is decreasing. Okay, so there are two other cases I'll talk about in a second, but the two main things to identify: is it positive slope, is the y increasing? Is it negative slope, is the y decreasing? there is zero slope. That means the y stays the same as x increases. So that could happen, and I'll show you examples of that. There's also undefined slope, where the x doesn't change at all. So you have zero slope, y remains the same as x increases. Okay, so as x moves along, the y doesn't change, and then there's undefined slope. In fact, the x doesn't change at all. There is no x increasing. X does not increase, it stays the same. That is undefined slope. So what we're going to do is take a look at some examples of each. So if I take out a blank piece of paper, I will draw a couple graphs for you and give you an example of something with positive slope. So if we have a coordinate plane, which again you must be familiar with. The coordinate plane, you have your x-axis and your y-axis. And you're looking, as x increases, as x goes this way, a linear function that has positive slope will look like this. That means the y value continues to go up as x increases. So this is positive slope. You also have negative slope. And again, to demonstrate, we are familiar with the coordinate plane. We know this is the x-axis, this is the y-axis. And so, as x increases, as x gets bigger and bigger and bigger, negative slope would look like the y value is decreasing as x moves on. As x goes forward and forward and forward, x is getting bigger, 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 the y value is getting smaller, smaller, smaller. That is a negative slope. So now we know what negative slope will look like. So there are two other cases. I talked about zero slope, right? Well, what if the slope is actually zero? So again, we have our coordinate plane, x-axis, y-axis. So zero slope means as x moves along, there is no change in the y value. That means the y value is not going up or not going down. The y value is remaining constant as x moves on. That graph would look like this. That is a zero slope. Okay, so this is a slope of zero. And the slope of zero looks like a horizontal line. So we can start to remember that a zero slope line is also horizontal. Just like the horizon. The horizon, sun sets over the horizon. Horizontal line. So you picture the sun setting on the horizon. We also have a case where there is an undefined slope. I'm going to ignore that phone call. So we have an undefined slope where I mentioned that the x value doesn't increase at all. It's not moving. The x value doesn't move. So there is no change in the x value. An undefined slope means we have a line that behaves like this. It is an undefined slope. It's also unfair to call this a linear function because this is not a function. Remember, that's why we use the vertical line test. However, this is a line that has an undefined slope. That slope is undefined. And it is a vertical line. And so we have our examples of positive slope, negative slope, zero slope, undefined slope. So now there are ways to actually calculate the slope of lines. And we can use that with a little trick that you may have heard before, something called rise over run. Let me explain quickly. Again, slope. By definition, the rate of change of the dependent variable over the independent variable. The change in y over the change in x is slope. The change in y is this way, we call that the rise. The change in x, which goes this way, we call that the run. So slope is rise over run. Now you know why we call that rise over run. If you find 2 points on a line, so let's say you have a graph, and on that graph you are able to locate two ordered pairs on that line, you can actually count the slope, counting how much it rises over how much it runs. So if you find 2 points on a line, you can count the rise over run. For counting the rise, if you're going from one point to the next and you have to go up, that's a positive rise. If you're going from one point to the next and you're counting down, that's a negative rise. Very similarly with counting run, if you count the run and you're going to the right, that is a positive run. And if you go to the left, that is a negative run. So going to the right, positive, to the left, negative. So if you're going from point to point, give it the rise over run. So when you are calculating the slope, you state it as rise over run, and then simplify that fraction if possible to do so, which goes into the prior knowledge, making sure you understand how to simplify fraction. So those are the notes for actually finding slope. Let's get into a few examples of finding slope. So if I have a coordinate plane, and I have 2 points that make a line. Let's say I have these 2 points that make a line. Lovely drawing of a line, which you will see. So if I have 2 points that make a line, we'll pretend the line goes to that second point. We can find the slope of that line without even knowing the ordered pairs by simply counting rise over run. So we count from one point to the next. Let's say I want to count from this point to this point. I'm going to count the rise, and I'll use blue to represent positive. So it's positive 1, positive 2, positive 3, positive 4, positive 5. So this is a rise of positive 5. From that point, I'm going to count the run. How far over does it go to get to that second point? So I went up 5. How many spaces do I have to move to get to the second point? And since I'm moving to the right, I'm also going in a positive direction. And I'm going 1, 2, 3, 4 spaces. So I'm moving to the right, which is positive, 4 spaces. So I have a slope, a rise over run, of 5 over 4. Now I simply ask, can I simplify that fraction? The answer is no, I cannot. But some of you are seeing this a different way. Some of you are thinking, well, what if I don't start from this point? What if I start counting from this point? And I say, knock yourself out. Let's see what happens. So let's count the slope from the next point down. What if I start at the top point here? My rise is no longer positive. I'm going down, right? So I'm going down 1, 2, 3, 4, 5. And I'm using red to showcase that it's negative. So my rise, since I'm going down, is negative 5. And then I'm going to count my run. And my run is from this point to where I was counting to the second point on the graph. And since I'm going to the left, that's negative. 1, 2, 3, 4. And so my run is negative 4. Excuse me. So to calculate slope with rise over run on that second example, slope is still rise over run. That has not changed. Just this time my numbers are different. My rise is negative 5. My run is negative 4. This is a fraction that can be simplified. We all know a negative divided by a negative is a positive. So whichever way you slice it, you want to count from one point to the other, whichever way it works, you still have a slope of positive 5 over 4. Just make sure you know that no matter what happens, this slope is going to be positive. How can you tell? From what we did. As x is increasing, the y value is going up. This is a positive slope. So don't ever show a line that looks like this with a positive slope that has a negative outcome. You know that's not right. So you're going to have to think a little bit as well to double check your work. So let's get into another example to showcase that. Actually, in the interest of time, let me give you a shortcut. Here's an example of a line that has 2 points. We're going to find the slope. We're going to find the slope. So, here's our line. The change in the y over the change in the x, the rise or run. There is no rise. In fact, what are we even counting? Why bother counting? We know this is a horizontal line. We know there is no change in y as x increases, so we know the slope is 0. We know the slope is 0. The slope is actually 0, but let's showcase that. There is no rise. There's no rise at all. So what is the rise? The rise is actually 0. The rise is 0. And what's the run? Now don't tell me the run is 1, 2, 3, 4, 5, 6, because the line goes on forever. The run is who cares. The run is, doesn't matter what number you put in there, because 0 divided by it will end up in 0. So we'll just call the run who cares. And so our slope is 0 over who cares. And 0 divided by anything is 0. The slope is 0. So there are ways that you can not need to count. The same thing would work for a vertical line. And that is how you can find slope, by looking at a graph and by understanding what slope means. And I wish you luck, and we'll come back next time. We'll talk about ordered pairs and how we can use that.